Okay students, so let us study today about atoms and molecules. So we start our third chapter. Okay, chapter third in your CBSE 9th standard. Right? So we will study today about these atoms and molecules. We already studied about you can say whatever matter is there, and we already studied that what actually the matter is. In our previous chapter it was is matter around us pure. So we studied about matter. So what is matter? So matter, what we told that matter is any substance. Matter is a substance. Okay, so we can say that it is a substance. Okay, what? So which occupies space. And another thing which is having mass. So anything which occupies space and which is having mass, it is called as matter. Okay. So we discussed about matter and we discussed about whether pure substance is there or mixture is there. So different type of pure substances were there. It was element and compound. Then we discussed about mixture. So mixture was of two types: heterogeneous, homogeneous mixture. We discussed about suspension. We discussed about colloidal. Okay, colloidal solutions. Right, then we discussed about that how concentration of solution can be found. Right. So today we will be starting our chapter that is called atoms and molecules. So atom, already we are knowing that every type of matter it is comprising of atoms. So what actually an atom is, that particular point we should understand now. Okay. So in this, what actually an atom? See, in early 18th century, some scientists, even you can say that before 500 BC, our Indian scientists, they are given credit to actually finding out about this atom. Okay. So what it is there, they told that an atom, when we go on further dividing it, okay, a matter. So keep on dividing. So at one stage will come, when further this matter cannot be divided. Means you can say that this matter, what you are dividing it into small particles, that small particles will reach a stage where you will not be in a position to divide that matter. Okay, so that indivisible matter, a very small or tiny particle which cannot be divided, or you can say the tiny particle which cannot be further divided is called. At that time, that our Indian scientists, they gave name as Parmanu. Right? Okay. So they gave name as Parmanu, and later on some foreign scientists, they went for some research work on this matter, and they also came to the same conclusion that matter, when it is divided into further particles and one stage will reach when there will be a very small particle, very tiny particle. Even we will not be able to see that tiny particle with our naked eye properly. Okay. So that tiny particle will be called as an atom. Correct? So understood now that what an atom is. So an atom, what you can define. If you want to define an atom, then we have to define an atom as the smallest particle or the smallest indivisible particle of a matter. So what we can say in one small sentence? The smallest indivisible particle of matter. Understood? So the smallest indivisible particle of matter will be called an atom. Okay? Right. Understood? So this was there for an atom, and the discovery of an atom took place, you can say. So Democritus and Lavoisier, later on, these were the foreign scientists who actually worked intensively and found and coined the word actually atom. So Democritus and Lavoisier actually who gave that law of conservation of mass. Okay, so they coined the word atom. Atom actually it has come from a word that is called atoma. Atoma means indivisible. Atoma means indivisible. That is indivisible. Right? So, indivisible. Right? Okay, very good. So, this was the definition of an atom. Atom understood now? So, what an atom is? So, an atom is the smallest particle of matter. Smallest, tiniest, you can say that tiniest or the smallest particle of matter which cannot be further subdivided. Even you can say that it is not visible to the naked eye properly. It will not be visible to the naked eye properly. Okay, right. So now in this context, later on, that law of conservation of proportion, law of conservation of mass, and law of definite proportion or law of constant proportion came into existence. Okay, right? Understood? Right. So Indian scientists were there who gave this name. Okay. So the name was Pakuda, Katyana. So those scientists were there who gave actually the name Parmanu. Okay. Anu. So in Hindi, Anu means atom. Anu means atom only. Okay. Parmanu actually what we used to say that nuclear reactions are taking place, so the nuclear materials are called as Parmanu. Right? Okay. So, two laws were given at that time. So, what it was found? It was found that atoms, actually when we are talking about an atom, so we talk about one particular element. We talk about one particular elements. Okay. If we are talking about a particular atom only, of similar type of atom. What we say? Want to say that similar type of atoms. So similar type of atoms, how we will be getting? So this similar type of atom for one substance only. So it will be applicable for one substance only. Similar type of substance atoms, that is one substance. Okay. So then it is element. What we can say? It belongs to an element. Right. Then when we go for different type of different types of atoms. If in a substance you find different type of atoms, then it is a compound. Then what it is? It is a compound. And this atom, you can say, this compound will consist of different type of atoms. Different types of atoms will be there in the compound. Right? So it may be, it will be having more than one substance. More than one substance. And that will be called as molecules. So that same molecules are there. So this is called molecules. Molecules. But one more thing is there, that when we are talking about any diatomic molecule, that is oxygen gas, okay, diatomic molecules. So diatomic, you can say substances are like O2, oxygen gas, nitrogen. So in this case, similar type of atoms only are there. Okay. Though we call it as a molecule because two elements of oxygen, when it is combining together, it is forming O2 and N2. So though we call it as a molecule, but similar type of atoms are available here. So in diatomic molecule or triatomic molecule, similar type of atoms only will be there. But it will not be coming under the category of compound. Compound means when it is combining with any other element, different type of atom. So when matter was formed and some matter which was in the form of compound, then different type of atoms were discovered in that. Correct? So in that case, it will be called as molecules. Right? Okay. Good. So further we will be going for the John Denton's theory, or let us discuss about law of conservation of mass. Okay. So let us have a discussion on that. Before moving further, let us have a discussion on law of conservation of mass. So, law of chemical combination. So what it is called? Law of chemical combination. So laws of chemical combination means what? That whenever any chemical compound is formed, so actually what are the laws applicable? How that chemical combination occurs between different type of elements, between different type of substances, between different type of matter. Okay, so when different type of matters are there, then how that chemical combination takes place actually, whether there is any rule or not. Okay, so it was found that it is applying some particular laws. Okay, so the very first law is, you can say, law of conservation of mass. So law of conservation of mass actually is similar to conservation of energy. So what we have studied in conservation of energy? In conservation of energy we studied that energy can neither be created nor be destroyed. Okay, so energy can neither be created nor be destroyed. So before reaction, whatever is the energy, after reaction also same amount of energy will be produced. Correct? Okay. So in that same procedure it is there here. In this conservation of mass also same concept is being used, and that concept is in a chemical reaction what occurs? So you are going for some reactant and it will be giving you some product. This is only called as chemical combination. Chemical combination means what? There will be some reactant and that reactant will be giving you, after processing, it will be giving you a product. Okay. So that is only called a reaction. So what happens? This reactant, suppose something A is there and it is becoming B. Correct? What happens when we prepare rice, when we prepare some type of curry? What happens? We used to take some raw substances, we used to put some masalas and other things, and then we used to give heat and we used to cook it for some time. So what that is? That is the process through which chemical changes are taking place in that particular substance. which is being converted into B, and that food we used to have, correct? Okay, so that only it is there. Okay. So now this A, what we have taken as a raw substances, so this A will be having some mass. Okay, so it will be having some mass. So mass of A before reaction, okay, mass of A before reaction should be equal to mass of B. Okay, mass of B. B is the product actually. B is the product, but both mass is same. Understood now? What? Law of conservation. Conservation means what? It is not getting destroyed. It is not getting diminished. It is not getting reduced or increased of its own. Okay, whatever you are giving, the same amount you will be able to get it back. You will not be able to get it back more than the amount what you have given as input. So what you can say, this is the input. So mass of input must be equal to mass of, here also you can say must be equal to mass of output. Understood? So in a chemical combination, whenever there will be a chemical reaction, so in that chemical reaction, whatever you are getting, whatever you are putting, suppose reactant, so you are making something, suppose water, so hydrogen gas plus oxygen, then when you are combining them together, you are getting 2H2O, so this is water, correct? So this is liquid and water. So you can say that in this case, so this will be having some mass of hydrogen, and this will be having some mass of oxygen, correct? Will be equal to, so plus, both we are adding together, so we will be getting what? Mass of H2O, mass of liquid. Same to same, we must get, okay, same to same. In actual process, due to some reason, we may get less, but never we will be getting more. Never we will get more. Okay, in actual process, some loss is taking place. Increase in mass will not take place. Increase in energy will not take place. Loss of energy will be taking place. For that, so many factors are there. Different factors will be there. Okay, so those different factors will also be taken into consideration, like friction and other things are there in which energy is lost. Okay, so but never we will be having more than 100% efficiency. If whatever the message is there, we are giving some energy. Okay, so it must produce some 100% efficiency, but we are not getting 100% efficiency. It means some of the energy is lost in different form. Understood now? So how can we define this law of conservation of mass? We can define this law of conservation of mass as it states that the mass of reactants must be equal to the mass of products, or in other words you can say that mass can neither be created nor be destroyed. Understood now? Okay? Good. Right. So, note it down. Yes, this is reactant, this is product. We have assumed, just only assumption is there that any reactant A, which is transforming, which is changing its phase, you can say this product, okay, as B. And then mass of A and mass of B both should be equal. This will be as output, this is as input. Right. Good. So let us go for another law. And that another law is law of constant proportion. Law of constant proportion. So it is called, second law is there, law of constant proportion. Okay. So law of constant proportion, what it says, here you can see one word is there that is called constant and one is called proportion. Proportion, already we have studied in maths, ratio and proportion we are studying in maths. Okay. So proportion means what? In some fixed ratio, that is ratio, a fixed ratio. Constant means fixed. Constant means what? Fixed. Okay. So this law is saying clearly that constant proportion. Now, what this law says? This law says that if any substance, we are procuring that substance from various places. Okay, we are procuring that substance from various places. If any chemical substance is there, okay. So that chemical substance, if we are procuring from various places, suppose you are procuring it from Salem, then Ram will be procuring it from somewhere else, okay, from Erode, and Gopi will be procuring it from somewhere, from Chennai. Okay, suppose he has procured the same substance. Let us take an example of water itself. Okay, he has collected that water from Salem, Gopi has collected from Chennai, and Ram has collected from Salem. So he has taken from some lake, and he has taken from some tap water, and Gopi has taken from sea. So what is same here? Same here is water. So water is a chemical substance. Everything is a chemical substance, man. Everything is a chemical substance. Even we are a chemical substance only. In our body also chemical reactions only are taking place. So we human beings are also one chemical substance. Each and everything A to Z is a chemical substance. Everywhere chemical reaction is taking place, and due to which some formation of product is there. Okay, so everything is a chemical substance. Whatever we see, everything is chemical substance. Okay, right. So now suppose he has collected that water from Salem, from a lake. So that Ram has collected this water from Salem, right? Then going for Krishna, he has collected this water from where? He has collected from Erode, and that is tap water. And you can say Gopi, he has collected from Chennai. So from Chennai, and that is seawater. Now what it is there? So as per chemical combination, you can say, so chemistry says that a water molecule, that is what? A water molecule. Okay, so it is a compound, which is a compound of what? Of hydrogen and oxygen. So chemistry says that a matter, you can say water molecule, not a matter, a water molecule which is the compound of hydrogen and oxygen. So its chemical formula is given by H2O. So now you can say when we are going for ratio of its mass. So hydrogen mass is how many? You can say 2 gram. 2 gram of hydrogen, because two molecules there, 2 atoms of hydrogen and 1 atom of oxygen. So you can say 16 gram. Yes, 16 gram of oxygen. Now its ratio will be what? So its ratio will be 2:16, and that is what? 1:8. So this ratio, what this law of constant proportion, what it says? It says that this ratio 1:8 will be maintained, will be found in each and every this water, whether it is from lake water, whether it is from tap water, or whether it is from sea water or ocean or from anywhere else or from RO, if we are taking it, this ratio is not going to change. It will be having a constant proportion. Understood? Understood now what actually it says? It says that whichever is the source from where you are getting it, that substance will be having the same constant proportion of elements which actually that chemical combination gives everywhere. Right? Okay. So how we can define now? So we need to define. So what we can say that, so this law states, it states that a chemical compound, this law states that there will be a constant proportion of mass of elements. It is said that there will be a constant proportion of mass of elements of a compound right, irrespective, what? Irrespective of the source from which it is procured. It is procured or obtained. Understood now? So this law states that there will be a constant proportion of mass of elements of a compound irrespective of the source from which it is procured or obtained. Understood now? Okay. If you want, you can take the example of ammonia also. So ammonia, what you can say in ammonia, what happens? Whatever may be the source of NH3, so that is ammonia gas. So in this what happens? Nitrogen, it is having its 14 mass of nitrogen is 14 and mass of hydrogen will be 3. Okay, so this 3:14 or 14:3 will be maintained whatever is the method of source, whether we are producing this ammonia gas from natural source. Suppose we are getting this NH3 gas, ammonia gas from where? Natural source, or if it is you can say manufactured in laboratory, that is artificial source, that is called artificial source. Understood now? Okay, so if this ammonia gas, have you smelled? Okay, generally in urine or urinal, whatever that gas it is produced in urinal, that is called ammonia gas. Okay, so I feel that everybody is aware that how an ammonia gas smells, right? So NH3 gas, whether it is from that natural source or from it is manufactured in laboratory, that is artificial source, it will always be maintaining this 14:3 mass everywhere. Okay, so this law, right? Okay, thank you. So next class we will be going for Dalton's postulate. Okay, so that Dalton's postulate is very important. Later on, Dalton also he found that atom is an indivisible particle and he gave some postulate. In that postulate, both these laws comes, right? So in next class we will be discussing about Dalton's postulate. Okay, thank you. So note it down, right?